I guess we could start. Hello. My name is Alex. I'm also known as SmartCloud on GitHub, and I would like to do like a short of the CAF talk about how we release TigerBeetle. Like again, this is like not really prepared. I haven't timed the talk. I like spent 10 minutes preparing the slides, so this all is deeply under construction. And yet still, I have a bunch of strong opinions I'm going to share with you. And the first opinion, which might not be particularly strong, but still interesting, is that release is kind of like a build. And I will disappoint you because most of the time I won't actually be talking about release process. I will be talking about the general build process of TigerBeetle, the TigerBeetle database. Okay, so to kind of like explain you how we arrived at this like slightly unorthodox build process for our database, I need to share like my experience how I ended up here. So originally I was hacking on IntelliJ plugin for JetBrains, and that thing was built with Gradle. And experience with Gradle taught me two things. First of all, there is no upper bound on the amount of complexity you can stuff into your build script. Like really, Gradle manages to do simple things using very complicated abstractions, like very opaque DSL. So kind of like you can easily acquire loads of accidental complexity. At the same time, Gradle has one thing which is like absolutely unparalleled, and that is a Gradle wrapper script, which allows you to like clone the repository without installing anything else, run this single script, and get the build of your software running, because that script kind of like self-bootstraps, it downloads Gradle, it downloads all dependencies, it's like does everything. So that's kind of like Gradle experience. Then I was helping with maintaining Cargo, the build system for Rust. And Cargo is kind of like well-loved in the community. And the reason for that is like that Cargo in the opposition to Gradle is like stupidly simple. That's kind of like, double-edged sword, because simplicity means that you can't actually do a lot of different things with Cargo. Like the build is fixed. Like you either do it the Cargo way or you don't do this at all. And some people view this as restricting, but actually if you scale this to the whole community of Rust programmers, you realize that this simplicity and restriction allows you to combine stuff from the whole ecosystem. So kind of like flexibility is good for a single project. It is bad for the ecosystem. After that, I started my kind of like personal. Yes, someone is raising their hand. You can ask questions, of course, as we go.
Thanks, Alex. I just want to put a pin. You just made a strong statement, like flexibility is an anti-feature for maintainability. What did you say? If you could just put a pin in that and come back to it, you can continue and you can just revisit.
Flexibility is an anti-feature for an ecosystem. If you are building a single project, then for like you as an author of this project, extra flexibility in your build system is a good thing, because you can do more different things. However, if you have an ecosystem, if you have 10 projects, and every project is built in its bespoke, unique way, then you lose the ability to automatically combine all projects together. So while you want flexibility for each single project in the ecosystem, for the ecosystem as a whole, it's actually better if there isn't any flexibility. If there is rigid set of things how you do stuff. And that is kind of like interesting point about Cargo, but this isn't really relevant to our talk today, because we are discussing releasing TigerBeetle, and TigerBeetle is like very specific single project. So we kind of we do care more about flexibility in our use case. Okay.
Cool. Thank you.
Yeah. Let's move on. After kind of maintaining Cargo, I started my own real project, Rust Analyzer, where I was in charge of a build system. And I kind of tried really hard to really make building Rust Analyzer an excellent experience. And kind of my personal opinion is that the reason why Rust Analyzer was so successful, and well, it was extremely successful, was to a significant degree because, well, building a Rust Analyzer was easy, and hacking on Rust Analyzer was also easy. Rust Analyzer is open source project with thousands of contributors. In that context, your build experience absolutely like dominates most of the things. If you think about like, company where you have a more tightly knit group of people who hack on software, then you might get away with like slightly less convenient build, but still I think even in company context, better, simpler builds are important. Another thing I learned while hacking Rust Analyzer is that, well, I kind of decided that, well, build of Rust Analyzer is complex because there's like language server, which you need to build for different operating systems. But then there is also a plugin for VS Code, which is written in TypeScript, but you also need to build that and you need to lintent, and then you need to upload this to a VS Code marketplace. So it's not simple. And I like did a crazy thing. I kind of wrote that entire build script just in Rust, not using like make, not using like Gradle, not using like anything complicated, just straightforward Rust code. And like that taught me that actually like you don't need Python, you don't need Bash. You can use Rust or Zeek or whatever to just write this build logic, because like there's like no requirement to have a scripting language. Finally, the anti-dependency. I haven't yet used like big build systems like Bach or Bazel or Nix. And my hypothesis is that if the task you face is to build a large ecosystem, like you have like thousands of different projects, thousands of binaries, and you want to release them in the same way, you really should look into these kinds of tools. But in my context so far, and in TigerBeetle as well, what we are building is actually a single tiny thing. Like TigerBeetle is tiny, it fits on a single floppy disk. So we kind of like on the smallest side of the scale here, and we don't need to use super gigantic, super advanced build system. So okay, like what is a build? And surprisingly, I think like it is at least 3 completely different things. And it would be helpful if you in your head kind of like separate build into its principal components. So on the one hand, a build of a software is just a sequence of commands you need to execute to arrive at a particular result. So if we want to release TigerBeetle, then we need to build TigerBeetle. Then we need to build TigerBeetle for each of the platforms we support. Then we need to build each of the client libraries. Finally, after we've built the stuff, we need to test it, and then we need to upload artifacts to NPM or NuGet or like whatever else we are uploading stuff to. So kind of like, but in that, it's just like a sequence of steps you do. Then, when you actually build software, in the sense of when you compile things, you also want your compilation to be incremental. You don't want to like do the work from scratch. So build is also about having some idea about interdependencies between commands and having an ability to figure out what is the minimal set of commands that needs to be rerun if you change a single source code. So kind of like the second aspect of building is this incrementality. And finally, there is like the third aspect, that build is an entry point. Like when you start hacking on a project, the first thing you need to build it. And then you you type make install, or maybe you do type cargo test or whatever. Like there is like this entry point, this interface of the build systems. And these are kind of like actually all lumped together under build, but they are pretty significantly different. So what is the best way to build stuff? And again, we are short of time. This is like off the cuff talk, so I will be presenting my strong opinions without proper justification, but we'll have hopefully some time left for the questions where you can like grill me and like try to prove me that I am wrong. So the entry point. The entry point is crucially important. It's kind of like, if you're hacking on the same project for like 5 years, you might actually become insensitive for the pain of a new developer, of a new contributor who comes to your project and tries to or read the docs and try to build it and try to test it. But actually, it's kind of like the reason why it is important for senior developers to focus on this entry point experience and to make sure that, hey, kind of like if you want to start hacking on the project, it is utterly trivial. And the best example here is like Gradle. Again, Gradle deserves a lot of scorn for how complex it is, but this entry point experience is like perfect. You just clone the repo, then inside this repo, you run this single script, which is there without installing anything else. There is no like apt-get install Gradle before that. And the build just works because that script goes and downloads Gradle. And then that downloaded Gradle jar actually starts, running the actual build logic. And this is kind of like a huge pain point in that there isn't a good cross-platform way to organize this entry point. So you need some kind of a hack. You need two scripts like for Bash and for PowerShell, or you need actually portable executable, or maybe you even need some kind of crazy hacky polyglot script, which is simultaneously a PowerShell script and a Bash script. But well, you need to solve this problem. And similarly, this is the reason why it might not be a good idea to write your build logic in, say, Python, because how do you install Python? Installing Python is actually, 5 years ago, it was completely train wreck. Today, it is slightly better, but still kind of there's extra steps until people get to use your product. So in TigerBeetle, we don't have quite that experience yet because you have to type more commands and they are longer. But the principle is there. So you clone repository, then you run a single bootstrap script which downloads the Zig compiler. And then the Zig compiler is the entry point. The Zig compiler is all you need to build and release TigerBeetle. So then you run Zig build scripts --ci, and that that there is 4 arguments build scripts --ci is actually bad. That's not how you should do this, and probably in the future we'll simplify it. But the idea is that now this CI is your entry point, and it's clear for everyone how to run it, and it's clear for everyone to where to find the extra build logic, because one of the anti-patterns of the entry point is that you don't actually have you don't actually have the single entry point. You have a dozen of entry points which are spread out across 5 different YAML files in your repository, because what actually drives the build system is some GitHub action automation. So this is bad. You do want to have clearly documented a clear entry point in your project. Yeah. Then how do you deal with incrementality aspect of the build? Well, you use a real build system. For Zig, that is Zig build. For Rust, that's going to be Cargo. But the trick is, if you if your underlying system is incremental, you don't need to think about incrementality when you orchestrate the build. You could just do X, Y, and Z, and rely on the internal build system to not do X if X is already fresh. So yeah, you still spawn an extra process to do X even if it is fresh, but that's actually fast. So you want to have incrementality at the leaf level of your build system, but at the top level, just a sequence of commands is usually fast enough. And that means that you actually just write a single script to do your build. And the question is what language do you use for writing a script? I kind of said that, hey, you shouldn't use Python because installing Python is painful. You shouldn't also use Bash because, installing Bash is also painful because, not everything is a Unix. There's Windows, for example. And then even on Unixes, Bash is different between different versions. On macOS, you now have ZSH. And for example, you have grep in Linux and macOS, but grep behaves differently. So Bash is a ton of accidental complexity. If you add your automation as a Bash scripts, then you also would probably add shell check script to check that your build scripts are correct. And then you write automation to check that your automation is correct. And this is just there's something you could not do if you pick a better language. And what is a better language for writing this kind of automation task? And my answer, again, strong unorthodox opinion, is that this is the language which you already use for your project. So if your project is in Rust, then write your build logic in Rust. If your project is in Java, then write your build project in Java. If your project is in Zig, then write your build in Zig. And that's what we do in TigerBeetle. TigerBeetle is in Zig, and we write build scripts in Zig. Zig is a horrible language for writing scripts because, you need to manually manage every string which is located by Zig, but it is still good enough. Like, you could write a nice library which abstracts this all away, and it is like maybe like 2, maybe 3 times larger than Bash, but it is cross-platform. It works the same way on Linux, macOS, Windows, and it is way more understandable. Like, you don't need to know all these like arcana rules with how you should quote your dollar variables. Otherwise, you would have word split and God knows what semantics in Bash. The core idea here is that you shouldn't, just take your standard library and go and write everything, because standard library usually lacks convenient API for scripting. In particular, when you script and you run a shell, a sub-process, if that sub-process fails, if that sub-process returns non-zero error status, you definitely want to throw some kind of an error from your build script. And this is something that typically standard library doesn't do, because process returning non-zero error status isn't actually an error from a operating system point of view. It's like normal outcome. So you need to have some extra helpers which provide you the right semantics. Similarly, when you create a file using your standard library API, if a directory does not exist, this function throws, so you need to create directory separately, and that's also a pain. You need, write convenience function to create a file and also create all required parent directories automatically. And it's not hard to do. You could find dozens of libraries on the internet. Like, I suggest this library for Dino, DAX, as kind of the model of how you should do this. But also, it's it's not hard to do this. I just wrote this library for Rust Analyzer. I wrote a simple library for TigerBeetle. It's not rocket science. The only messy part is argument parsing. And for argument parsing, you do want to steal someone else's work. But again, if you can't, because Zig is a funny Yellow language and dependencies are painful, you still can handle it pretty decently. So let's actually the proof is in the pudding. Let's look how horrible it is to use Zig for scripting. So what we are looking before I start, is the font large enough, or should I embiggen it a bit?
It works for me. I don't know if it works for everybody else.
Okay, so if you can't see, but also you can't talk, then sorry, you're going to see it later on recording with a magnifying glass. So what we're looking at is a build script for TigerBeetle, which actually goes and produces a release binary. This all is relatively simple. So here we need to use this tool called LLVM LiPo, which I don't know what it does, but it is could be named differently. It is either LLVM LiPo or LLVM 16. And we just go and for each one of them we try to execute this tool version, and if that succeeds, then that one works. If it didn't succeed, then okay, we try the next one. If none of them succeeded, we fail with error. Then we go and iterate over debug and release build, and we iterate over all the different targets we built TigerBeetle for, so macOS, Windows, Linux, and we just we just go and call Zig build install target blah 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 blah. So again, it's a wall of text. You would have a similar wall of text in Bash. It might be maybe 2 times smaller, but it would have twice as many bugs, and it would be twice as hard to get consistent behavior on Windows and Linux and macOS. While this is pretty much guaranteed to work more or less correctly everywhere. So yeah, that's kind of it. Again, kind of this. This is what I'm showing about. This is this library. So there isn't. So you see, I run this subprocess, and instead of manually constructing this array of arguments, I just write a single string literal like I would do in Bash, and then I use variable substitution similarly to how I do in Bash. This is not something standard library provides you with typically. But it's also not super hard to write. And well, of course, if you're writing this, you need to be careful to avoid shell injection, to not actually concatenate strings and then split them by white space, but also always maintain this array of strings inside, which again, you as a library author can do better than it is done in Bash, because Bash is absolutely horrible for splitting things on white space here and there. Similarly, this is another helper function to copy file without caring about whether the parent directory exists or not, and which actually prints a nice error message if stuff fails. So just simple library. Okay, so let's get back to our slideshow then. Okay, and we need to find out where we were. Okay, that was kind of the part of the talk where I was describing the general build. Now let's come back to releases in particular. Now that you have some tools to, in general, manage the build of your software, how you use these magic mechanisms to do a release. Well, no single story here, just a bunch of anecdotes. And the first anecdote is that, well, you should do frequent releases. All else being equal, releasing twice as fast is better than releasing with the frequency you are releasing. And that is kind of an instance of a general pattern I see all over the place in programming. And that pattern is reverse triangle inequality. If you need to go from A to C, it is faster and shorter to go first from A to B and then from B to C than to go from A to C. Don't submit giant pull request. Submit 10 small pull requests in incremental step. Don't write a giant commit, split it in 2 commits. Don't make a giant release, make a small incremental release, so that on every release, you kind of spend only a little amount verifying the diff of this particular release, and the total sum would actually end up being smaller if you try to release all the changes at the same time. Because if you release frequently, then the changes in this particular release are very fresh in your mind. So you know what you're releasing. It takes less effort for you to write the changelog, to do any extra testing, to realize whether you should release it, or is there any risky changes you might want to back out of the release, or something like that. So for TigerBeetle, we aim at weekly releases, and well, not aim, we actually do weekly releases. We kind of we don't have our 1.0 super production ready binary, but we already have releases. You can already download TigerBeetle, and every Monday, like a clockwork, there is a release. We change that and whatnot. Another nice point about these weekly releases is that they give you a marketing point. So every week, when you do a release, you can actually, go and tweet the changelog. And well, maybe someone reads this 10 item point changelog and finds one item they can relate to, and then you will tweet, and they will say, hey, actually, they did this thing today, and I love it, and that's great. And if you, do a single giant changelog with 1,000 changes and not 10 changes, then that person wouldn't actually find that change, because it will be buried somewhere, deep in the changelog. They wouldn't have time to, read your entire changelog. Well, in small pieces, everyone is happy to do this. Again, experience with Rust Analyzer. Every week, Rust Analyzer does a release, and every week there is a post on Reddit with new features. And again, there isn't a lot of discussion, but there is always this constant engagement with moderately active level, and someone says, well, you did this feature, it is great. This is also good for giving credit to your contributors, because when someone contributes to Rust Analyzer, the very next week they see their contribution go live, and it is extremely gratifying when you you did the work, and then less than a week later you can actually download the production build and see that, hey, this thing is deployed. This also, weekly cadence is also great for internal dynamics in the team, because in a team it is always hard to keep large picture in mind, because you hack on what is your current task, and you kind of ignore what your teammates are doing. And this weekly release pulse provides like, a synchronization where everyone can read a changelog and pause and realize, wow, maybe I wasn't productive this week, but as a team together, we did like a whole bunch of different stuff. And yeah, one kind of like thing I want to add here is that like Andrew of Zeek like complains that, hey, kind of like writing changelog is hard, it's a lot of work. And it's like true, like, if you look at the Zeek's changelog, it is like it's gigantic document. Like it's like a Tolstoy novel. Like you read and read and read, and there's like no end to it. And it absolutely like takes weeks to write it down. And my humble suggestion would be to, well, maybe you should do frequent releases. Maybe if you do a release every week, then writing a weekly changelog wouldn't be such a slog, because, well, you just, you merged those pull requests a week ago, so you know how to write it, and then you can, like, actually make use of this reverse triangle inequality and provide like the aggregate, the same amount of information, but it just takes less time for you to write all this, and for users it takes less time to upgrade, because every upgrade is less risky, because every upgrade is small and you can carefully consider each change. Okay, so frequent releases is kind of like, I guess, the primary thing you could apply to your release process to make it better. The second thing is this non-rocket science rule, which was popularized by Gray et al., the original author of Rust. And the idea here is that, your project has like a main branch, and the main branch should pass all tests all the time. And this imposes a restriction on how code gets into main. So traditional approach is that you commit code into main, and then you run tests, and then if something's broken, you go and try to fix it up. Or you submit a pull request, which is a separate branch. You run tests on that branch, and then you merge this branch if the test is passing. But actually, the state of code on the branch and the state of code after the branch is merged might actually be different due to merge conflicts. Like, I don't know, like even like the hash of a commit is different. Like the state of a code is determined by commit hash, and between the branch and the merged main, the commit hash is different, because, well, on the main you have like this extra merge commit, and well, that means you are testing different code, even if there isn't like even if semantic differences are unlikely, they might be there. So the process you want to have here is that you have a branch, then you create a merge commit, and you test this merge commit. And only when this merge commit is successfully tested, you atomically upgrade the master branch to point to it. So you can only advance the master branch to a different commit if you have a proof that that commit passed a set of automated tests. And this kind of like opens up a question of what is a test? And like, some people think that like tests are integrated tests, some people think that tests are integrated are unit tests, but you should like, open the doors of your perception. You should broaden your horizon. So test is a predicate about source code. That's what it is. And like any predicate, you can check in an automated manner, you could put it into the tests. So you don't need separate infrastructure for linting, for spell checking, for formatting. These all are just tests. And these all should be driven from the same entry point you use on your CI to like, run the test. So there shouldn't be extra steps in the CI to run tests and then run formatting and then run linting. No, there should be just a single line in CI which says, hey, please verify everything. And then inside your build system, you actually do these three separate things, maybe in like different threads, formatting, linting, and spell checking. Okay, so an non-rocket science rule is kind of like really, you should just have it. Like there's no argument about that. Like if a project doesn't have non-rocket science rule, that's like an easy way to make development of this project easier. Okay, next, distributed builds. So kind of like couple of platitudes. First platitude is that distributed systems are hard, and like if you can avoid building a distributed system, then please avoid it. Like, okay, I haven't like it. I work on a distributed database, so like building a distributed system is like my job, but it is like freaking hard. Like I wouldn't recommend anyone to build a distributed system, so I'll avoid this. especially you should avoid building heterogeneous distributed system. If your distributed system is such that every actor in the system is kind of like runs the same code, is the same, then it is manageable. If the actors are actually different, then it is like crazy complex. And builds tend to be heterogeneous distributed systems because you have a Windows machine, a macOS machine, and a Linux machine, and they all need to run builds, but they are all different. And this is like crazy complicated. So you want to avoid that. So why we are even trying to do releases on multiple machines? One motivation is that, well, this is just faster. The building of software is an embarrassingly parallel problem. So if you spread it across a bunch of machines, it will finish faster. The truth is, like, modern machines like crazily fast. Like, you can compile the kernel, the Linux kernel on a laptop like in 20 minutes, and like kernel is gigantic. So unless your project is like on the scale of Linux kernel or bigger, you don't actually need distributed builds. You can build everything on a single laptop. The second reason why, you might want to reach for distributed builds is that you need cross-platform support. You need your stuff to work on Windows or Linux or Mac, and that requires you to spin Linux, Mac, and Windows virtual machines and do builds there. And, well, kind of like, maybe our answer to that is cross-compiling, but, well, cross-compiling doesn't actually work. You can't even cross-compile from Linux to Linux. If you build your software on modern Linux, it will only be compatible with modern Linux, even if you are only using the older features which are present in the old kernels, because, well, there is like glibc and glibc multiversioning, and this is like completely crazy. Like, if you want to build portable software for Linux, like the standard way is that you dust off your old laptop, which runs like Debian from 2006, and you build it on that Debian, because only that way you guarantee that your software runs on older machines. This is completely crazy, and there isn't good solutions there. Like, the only good solution is stop being a programmer and try to pick up gardening or something like that. Or you could use Zeek. Like, this is like one of the biggest force multipliers we get from Zeek, is that Zeek actually solves this cross-compilation problem. Zeek actually goes and hacks around this glibc multiversioning thing. So you could say to Zeek, hey, Zeek, please compile my software for glibc version 2.1, even if my current version of glibc is 2.95 or whatever. I don't even know which glibc version I am on, because after I use Zeek, I stopped caring about this problem, because I write it once and I build a script and it's done. So yeah. Bottom line is that try to avoid distributed builds. If you're not using Zeek, you might have to incur them. And if that happens, well, that is part of accidental complexity which you just have to solve. But at least try to minimize the amount of distributed building you need to do. Okay, so without further ado, let's actually look at how we solve this distributed build problem in TigerBeetle, to give a specific example. So for release, the entry point is a release.yaml file, which is a single GitHub action. It is not super tiny, 68 lines, and most of it is setting up dependencies. So you see, what I use GitHub Actions for is installing .NET, Go, Java, and Node. And I'm not a fan of GitHub Actions, but here, again, this is a hard problem. Installing Node.js on 3 different operating systems is freaking hard. And you want to solve this in some principled way. I don't want to write this code myself. So again, I kind of begrudgingly agree that, okay, we'll use GitHub provided actions to set this up. But then for actual build, you see there isn't there isn't any logic encoded here. I just do this install Zeek from the entry point slide, and then I write this single command. I just say, okay, now that we have Zeek, then please compile the scripts binary and run the release command, which should build software, and it should publish software. And here is the version we use for publishing, and here is the git commit hash of the code which we are building. Then in this scripts So let me split screen, scripts, Zig. Yeah. So this script thing here is this main function, which has a release subcommand. So if the user passes a release argument, then we run this logic. And this is the file which we've already seen today with that FN build TigerBeetle thing. So here we just, do the build. And this single program builds the entire release. So it builds TigerBeetle server, it builds client libraries, and it builds TigerBeetle server for every architecture. So all the cross-compiler is encoded directly in this script. And again, there is just some simple, straightforward scripty code. So if we want to compile Zig, then we compile Zig. If we want to compile .NET, then we compile .NET, Go, Java, Node. And compiling any one of them isn't super complicated. So you just do some basic shenanigans to run npm version, npm install, npm pack. And here you sometimes want to fight, because if your project is heterogeneous, if you have Java, Node, and Go, and you want to all of them behave the same, you might actually want to fight against npm versus Maven versus Go toolchain, which all have slightly different opinions about how software should be made. But well, again, you're a programmer, you could write arbitrary logic to fix this up. So yeah, I guess that's kind of the part of what I wanted to show you. And the main idea here is that, we just run this on Ubuntu latest. There is no distributed systems aspect to it. We just run a single build, which builds everything. Again, it is not super fast job because it needs to compile combinatorial explosion of things. It takes, I don't know, 20 minutes, I think, or something like that. But because it is a release, this isn't something which is run on every commit, which is only run when we make a release once a week. It's actually not too painful that it takes a while. And it is way less painful than if we try to distribute these across 3 different machines. Okay, so let's go back to our slides. What else we have here? Yeah, two-phase release. Finally, this is something we have planned but haven't yet implemented fully. And the idea here is to extend not rocket science rule to release as well. So not rocket science rule basically enforces predicates about your code base. And if you have not rocket science rule, that means you actually don't need to run tests during your release process, because you release from the main branch. And for main branch, you have this invariant that it passes the tests. So you don't need to rerun the test. You already know that if the code is in the main branch, then by definition, it was tested, and you can't uncover any more problems just rerunning tests. But what you release isn't actually source code. What you release is binary artifacts. So you compile your source code using particular compiler settings to binary, and then you ship this binary to the users, and you say, hey, this binary, use it. And that means that you actually want to have extra checks for this compiled binary. So ideally, your build process should be, your release process should be two-phased. In the first phase, you compile the artifacts, and you maybe even sign them. And then you publish them to some staging area and say, hey, this what release is going to be. Then you run extra automation with integrated tests, which test not the source code, but the actual build artifacts to suss out any bugs which might have crept in between source code and compiler. I don't know, maybe you updated the compiler and it misoptimizes the code or miscompiles or something like that. So you want to do this extra level of protection. Or, for example, what we are going to do in TigerBeetle, you want to spend 10 CPU years fuzzing this particular binary. After you accumulated sufficient proofs that particular artifacts are good, you can actually then go and release those artifacts. So you could take these artifacts from this stage in place and publish them to NPM, to Crates.io, or whatever you need to publish releases to. Unless, of course, you use Java and use Maven. Like this is infuriating. So Maven doesn't really have a super nice way to say, hey, don't build the code. Here is the jar file which I have built on a different machine. Please just release this jar file onto the repository. Well, at least, or maybe I haven't found a way to do this. Like because what I want, this is what I want to do. And what Maven does is it insists that, hey, I'm actually going to run the entire build. I want to like compile stuff, run the tests, package the jar, and send the jar. And well, I don't want to send a different jar. Right? I already have the jar, and I want to send it. And it's funny how, like, I googled it, and there's like no information on the internet except that like this single forum post from 10 years ago, where a person describes exactly the problem I have, like building release, then running extra validation of the release, then releasing the actual release artifacts, and well, there is no answer there. So yeah, I think that's all I wanted to share about how we built and released TigerBeetle, and we even have plenty of time left, so I'm here to answer any questions you have.
Thank you. Took me a while to unmute. I have a bunch of questions. If nobody else wants to go, I can start. So did you write your build script in another language before figuring out that you should write your build script in the language that you write your project in? Or was it something that you knew, or was it something that you learned?
This is something that I kind of like learned over history, because well, my first build script was written in like Gradle DSL in Groovy, and that was horrible. So like since then I kind of like, well, that was kind of like negative experience where I learned that, hey, actually, like having this extra thing is like painful. Another negative experience was actually when I was building Rust compiler, because like Rust compiler is built with make and then with Python, and it is like a horrible drag on productivity. So when I was designing like TigerBeetle Rust analyzer, I needed to find some way to run ahead of a compiler, because the plan was here, hey, we are going to implement all the same things that Rust does, but we are going to do it faster to like do the IDE things. And that means you actually need to move faster than compiler. And one way I figured out I could be faster is that I need to make build easier. And there I figured out that, hey, actually, if I don't have Python, if I don't have Bash, if I don't have Groovy, if I only have Rust, maybe it will be faster. And well, it turned out to be faster. The second experience was, well, when I came back to TigerBeetle, because, well, before I joined, actually, there was way more Bash in TigerBeetle than it is now. And it's like still way more Bash in TigerBeetle than I would love it to have. But I'm slowly kind of like chipping in at the complexity and rewriting Bash into Zig, and it seems like it becomes stabler. It becomes more reliable, more robust, and more easy to extend and to tweak, because you are not beholden to Bash idiosyncrasies, or to some other like build system which has its own like rigid ideas about how to do stuff. So yeah, that is learned for experience. But I want to emphasize that this is when you build a single project. Like if I were, I don't know, a technical directory for a company which shipped 10 different products, I would probably want all the 10 different products to be built in the same way. So I would maybe apply different solution there. But for the context of like Rust Analyzer or TigerBeetle, like this, hey, just write this in Zig or Rust is like perfect.
Thank you. I'll ask one more question before I give other people the chance. I missed when you showed your GitHub action, what actually triggers that action. So like what triggers the actual release?
It is actually right here. So
you have a release
what
branch.
triggers is like pushes to the release branch. So the overall release workflow for actually, why I can explain this when I can just show. So we have docs release. We have like release process document. And that's actually another like important thing. Like, for these processes, don't keep them in your head. Just write what you need to do. And this is how release works. On the main branch, you run this script, which generates the change log like template. then you manually, as a release manager, fill in that changelog. Then you submit a pull request with the changelog, and that pull request gets merged into the main branch. After the changelog PR merges into the main branch, you push that main branch to the release branch. And again, because it is in the main branch, not rocket science rule enforces that it is actually tested. So when it is pushed to the release branch, then this thing got triggered and runs the release. And there is like one extra nice thing. Well, I said I don't like GitHub Actions, but this thing is like actually brilliant. So this also like requires this release environment, which is just a bunch of secrets. So like all those things are like needed to like actually push code to repositories. And GitHub allows you to say that if an action runs in an environment, then it must be approved by someone else's different from a person who originated in action. So if I push to the release branch, I cannot approve this action. Someone else from the team needs to do this. So if you break into my house while I'm giving me a presentation and like, club me and steal my laptop while it is still unlocked and go and try to do a TigerBeetle release, you actually won't be able to do because it will require like approval from someone else, and someone else obviously wouldn't approve a release on Thursday because we release on Monday. Well, we actually, small that we actually plan to release on Friday when we do this two-phase thing. So that on Friday we do a release, then over the weekend we bake it in our fuzzer, and then like on Monday we do like the proper release. But actually it happened on Friday. So yeah, that's it. And well, there is the problem with GitHub Actions. Even if you minimize the scope of GitHub Actions, there is like still this like stupid problem that you need to debug them. You cannot debug them locally. You just need to add prints and rerun. And that's why there is also this, hey, you could manually kick this in to make it work. While we are on this, I realized that I forgot to show one extra thing, and this is our release validate workflow. So TigerBeetle doesn't have dependencies, but TigerBeetle client libraries do have dependencies. In particular, they depend on particular runtimes. We depend on Node.js, and we depend on Go and on .NET. And if, for example, Node.js releases a new version, which actually breaks our client library, well, probably that is a mistake on the Node.js part, but we still want to detect this. So we have this extra thing where we, on a cron, run a job which tries to install the actual latest release and run a bunch of sanity checks there, just so that we know that releases that we did in the past didn't go broken due to some changes in the operating system's API or languages or whatever, just, as a sanity check. And, well, also, of course, as a sanity check for maybe we released a broken version. We sent something correct to the NPM, but there is some horrible corruption in the wire, and what ended up on the NPM is actually different. So here we do this extra validation of hey, let's just NPM install what is actually there.
Thank you. This is so cool. I'm so excited about this. Max, you unmuted.
I was gonna ask, so I'm guessing each client, it doesn't necessarily have to have any changes for it to get released. It's all under the same version of TigerBeetle, the same thing. The clients are all under the same version.
Yeah. So that's a good question. Our versioning strategy is that we just use sequential version. So if you go to the release.yaml, you see that the version we pass in is .14 .point_release number. Run number. So this is just a sequentially incremented thing. We haven't yet fully committed to Semver or whatever, so that's what it is. And we kind of don't really care about those numbers. So if if there is a release where Java client has changes, but Node.js client doesn't have changes, we still release both of them. We release the whole package as a single consistent thing. And this is actually also interesting because we don't try to keep this number sequential. So maybe some release is broken. Like, maybe you release version 100 and you successfully release version 100 of Node.js, but then you failed when you tried to publish Java. Well, that is okay. We just go and immediately rerun this with the next release number. So that, this actually reminds somewhat like the consensus, where you sometimes need to truncate messages from a previous view. So kind of every release number isn't guaranteed to be correct, but if something gets broken, we just release immediately on top of it with the new release number, even if the code is the same. I'm not sure if that answers the question, but I tried.
Thank you. So then the clients are being tested against that new upcoming release version of the library, right? So we have to build TigerBeetle first, and then have all the individual clients run unit tests against this newly built version of Zig, and then only then it's good. So I'm guessing it doesn't really happen often where you have I don't know, Java fail but not Node, because they're all sort of.
Yeah. We do upgrade them in lockstep, and right now we say that, hey, you should use exactly the same version of the client library and the TigerBeetle. And in particular, we had this a fun bug in release validate code where we downloaded release, but we were actually running the tests written against the main branch. And in that case was broken. So that's why we kind of added this extra condition here, which says that, hey, actually you always should use the code of the release to test its release, because master might be different. Again, this is something we'll hopefully fix by having proper compatibility in the future, but compatibility is actually hard. Again, avoid building distributed systems, and if you can avoid it, avoid promising severe compatibility, because it is very helpful for your consumers, but it is also very hard for you to maintain. And you can have production-ready software which doesn't guarantee fully compatible interfaces. For some, not for all cases, but for some cases, your consumers actually are going to be okay with upgrading their stuff when you release new version. And that's what we aim at with TigerBeetle. We first do a production release, which doesn't guarantee full API compatibility. After we are careful with that, we pick up extra work and we do enforce severe compatibility. But that comes later, because the worst thing you could do is that you promise severe compatibility and then you break it because you didn't realize how hard it is, because compatibility is freakingly hard. And if you can help it, avoid it.
I think that also makes a lot of sense when it comes I think individual libraries make sense to do similar, but you're shipping this not in a vacuum. So obviously you have to, it makes sense for users, oh, this version is the same as my Node client version. So I mean, in some cases, it makes a lot of sense to not follow it at all and just come with that expectation. So
yeah. Because our client libraries, they're libraries specifically for TigerBeetle. They are not general purpose libraries. So if you're building some general purpose library for parser combinators or whatnot, then you have much higher motivation to do somewhere from the start. But if you because we don't expect that there are going to be a lot of libraries which depend on TigerBeetle library. We expect the TigerBeetle library is going to be used by the end applications, which are generally fine with upgrading, because that's the thing about Sandware. Sandware is about coordinating upgrades across the ecosystem. It is not about making your life as an application developer easier when you want to upgrade your dependencies. Sandware is when you transitively depend on foo through library A, and you transitively depend on foo through library B, and library A and B are written by different people, and you still want those two different people without coordinating, somehow specify a requirement which works for you as an application developer. So that's what Sandware is about. It really isn't about just upgrading your direct dependencies. But if you don't don't intend to be a transitive dependency, and we are not really intend to be transitive dependency with TigerBeetle libraries. You actually can be much more lax about Semver. So again, not saying Semver is good, not saying Semver is bad. Semver is excellent tool for what for the problem that it solves. But it's important to realize whether you actually have this problem or whether your problem is different.
Thank you. Anybody else? Any questions?
So why is TigerBeetle on 0.14 now? Like, what's the 14 and what was 13, and why did you choose?
Like it's okay. So like again, this is not the first. I mean, I think there is even like 1.0 of TigerBeetle published somewhere, like by accident. So it's not that there is like particularly wise decision there, because we are iterating on this release process, and like this release process is less than a year old. So 14 was the biggest release number, higher than anything else we have released previously, because previously we like tried like some different crazy release numbers. So again, this is like just a number.
Cool, thank you. Any other questions? Getting close to the end, and I know some people have to hop.
I have a question. When would you consider switching to something like Bazel?
Yeah, so I guess there are like different things. One is that I manage an organization with heterogeneous projects. So if I have an org and one project is mostly C++, another project is like mostly Java, and yet another project is mostly Go, I would strongly consider to using a unified build system for all those things, because I want to reduce coordination overhead within my organization. I want my organization to be like a compact island in terms of communication. Another case, if I have if I have a project in C++, because like C++ build systems, like they are horrible. Like CMake is abomination. Like you shouldn't do that. And in that case, like Bazel might be overkill, but well, there isn't cargo for C++ here. Well, maybe one day build 2 will be this cargo for C++. I really hope, but like so far, my understanding is that like there isn't like one build system except CMake that wins, and CMake is horrible. So if I were doing C++, I would be inclined to pick Bug 2 simply because, well, that's better than alternatives. And finally, if I have a single project and this project is like gigantic, if I have like millions of lines of code, then I probably, at that scale, I probably do want distributed builds. I do want extra hermeticity, which is provided for me to me by Bazel. So for example, if I'm writing a Rust project and I know that my Rust project is going to be millions of lines of code, then I will actually switch from cargo to Bug 2.
Okay, thank you.
And we're at the hour. So thank you very much, Alex, for joining us this afternoon. For at least me, it's afternoon. And this was very insightful. Thank you so much.
Yeah, thank you for having me. Bye, because I need to jump as well.
Okay, bye.
Thank you.
Bye, everyone.